Hello everyone, this is a quick machine learning exercise. We're going to be using Bayes' theorem to create a quick machine learning model using the sklearn load iris dataset. So just to go over the quick Bayes formula, it's the probability of A happening if B had already occurred equals B happening if A had already occurred over the times probability of A all over the probability of B. So we're going to load up our Jupyter notebook. I'm going to call this Bayes iris because we're going to be using the Bayes iris dataset from sklearn. So let's load that up. So sklearn.datasets import load _ iris. And what we're going to do is we're going to set our x value to the load iris. Let's actually, just for fun, show you that we can save this data set into one single variable by doing this. And then we can now set our x to iris.data. Now, if you don't know what x and y really are for, y is your target. In supervised learning, you got to have a target. You got to have an answer key. So if it was predicting house prices, your x data would be the huge data set of like garage size, lot size, I don't know, if the basement's finished, how many bathrooms, how many bedrooms, the square footage of the entire house. And then your y, the target, would be the house price. So in supervised learning, you got to have that y target. So your x is all the data in load iris, but y is just the target. And sklearn datasets load iris, they do that all for you. So it's very easy in terms of learning machine learning models. You can use this load iris dataset for a lot of stuff. What it is, if you've never seen the load iris dataset, it's like septal length and petal length and all that stuff of different iris flowers. And the y target would be the actual name of the flowers. So this is name of flowers. And this is the flower details, I guess. Okay, so now we have to do a train test split. We have to tell our x and y's to split up so we can use some of it for training and some of it for actual testing. Training is like reading a textbook and trying to, answer the questions in the textbook. But you also have the y, which is your answer key at the back of the textbook. So once you finish a question, you can look at the answer key and you can confirm that your answer was correct. So let's import sklearn.model selection, it's called. I'm pressing tab there to autocomplete, and I'm pressing tab again to import train _ test _ split. This actually does everything for you. So we're going to do our x train. We want our x test as well. We want our y training values, and we have our y testing stuff equals. Okay, so we're going to now use the train test split, and it's going to ask us, so, okay, what do you want to, where's the data that you're going to split? Well, x, we're going to use x, and we're going to use y, right? So x and y are going to be split up. Make that a little bit cleaner right there. So x is going to be split up and y is going to be split up. But now it wants to know how much you want to split it. So the test size, we can make that equal to 0.2, for example, which is 20% of the data set. So x training is going to be 80% of the book. And the y training, the y train, is the answer key for that 80%. But then your x test, which is the actual test that you get on test day, that's going to be only 20% of our data here. And the y test is actually hidden. It's 20% taken out. That works with the x test. So it's the answer key for the x test. Now we're going to only use that to see what our score was when we finish actually writing the test. So now the test size is 20%. Let's do random state. So what is random state? I'm going to set it to 42. It's my favorite number, but random state here is like a seed value. If you've ever played Minecraft, you put in a seed and you get a map. Now, if you were to delete everything and open up a new world and put in that same seed, you would get the exact same map. So a seed value is essentially a predetermined set of values or numbers that we can share across computers. So if you were to put 42, our answers in the next code blocks or anything regarding this test are going to be the same. Now, if I used 42 and you used 41, we'd probably get different results. So let's all use 42 just for the sake of going through this walkthrough. Now we're going to import our naive Bayes GaussianNB, which is from the sklearn dataset. So we're going to, or from the sklearn library. So sklearn.naive. Let's see if it finishes it for me when I press tab. It does. Import. I'm going to put a capital G, and there we go. It finds that for me. And I'm going to save this into a variable, same way I did iris. So I'm going to do gnb, gnb equals our GaussianNB. So now what this is it's, well, this is you. And we're going to make you write the test now. So gnb.fit. Fit means go write the test. So what's the, or not, sorry, not go write the test. Go train for the test. So go practice for the test. So X train and Y train. So we're using the textbook, which is the training data, and we're using the answer key of that textbook. We're giving it to you. That's what fit means. We're giving you the textbook and the answer key for you to learn. So let's run this. And it says GNB is now this model. So your model, what type of model is it? It's a GaussianNB model. And it's running on the naive Bayes formula. So all the answers all the formulas that you're using on this data is the Bayes formula. And then you're checking the answer key to make sure that your answers are correct. And then here we go. We're going to get your actual test answers now. So now you're going to go do the test. So gnb.predict. Predict is actually the hard test that we're going to be making you doing. So we throw in the X test. So you are now given the test and you're supposed to make your predictions. So what your answers are after you've been trained, what are your answers for the X test? Well, here are your answers. We're going to save them in Y predictions, okay? I'm actually going to run that. Now, just so you can see what Y predictions looks like, I'm going to type in Y predictions, and here are your answers. So your answers are, I think it's the first flower type. And then the second question, I think it's the 0th flower. So this is technically the first, right? If you know Python, 0 is always the first, right? Index. And then we think it's this type of flower. And then, oh, we think this flower and this flower are the same, actually. So we're going to say 1. And then this one's 1. And this one's a 0 flower. So these are your answers for the test. Okay, so there's your Y prediction there. And then we're going to import metrics. And we're going to see what your score is for the test based on the actual answers. So here's the Y test answers, right? So I'm going to do... let's do from sklearn, we got to import metrics. And then we can do print you scored, and I'm going to put Bayes here just so you know exactly what you used to write this test. Then we're going to use metrics. Accuracy. Let's see if it finishes it for me when I press tab. It does. And now we're going to say the answer key first. So the answer key for the test is Y test. So the answers, which is Y, right, the targets for the test, and then your answers, which is Y prediction, right? And I'm actually going to multiply that by 100 so we get like a percentage score. And oh my goodness, look at this. Using the iris dataset, we made a model. And we trained that model, so they got that textbook and they read it over and they made sure that their answers were the same as the answer key in the back. It trained so well that it got 100% on the test. Very good. This is your Bayes machine learning model based on the iris dataset. I hope you enjoyed. Bye-bye now.